the line x plus y equals to 3 and the line x plus 4y equals to 8, where they intersect. From that point where they intersect, we have 4 major regions. Here is one region. Above this point, bounded by these 2 lines, is another region. The example here represented says, represent the region satisfying the simultaneous inequalities x plus y less than 3, x plus 4y greater than 8, and x greater than or equals to minus 3. Now, first of all, the approach is that we are going to first of all look at these inequalities as equations, as linear equations. Then we draw the graph of these equations. When we draw the graph of the linear equations, we now look at the regions that satisfies these simultaneous inequalities. We're going to first of all take the first one. I'm starting with the first inequality. For x plus y less than 3, we transform it to the equation x plus y equals to 3. Now, this is the linear equation. Now, to graph this linear equation, we will need to get the x-intercept and the y-intercept. For the x-intercept, we are going to set y equal to 0. When we set y equals to 0, we have x plus 0 is equals to 3. Therefore, x is equals to what? 3. Now, we're going to have the intercepts. The intercept we have here is when x is 3, y is 0. Now, next, we are going to look for the y-intercepts. The y-intercepts. To get the y-intercept, we set x equal to 0 in that equation. When we set x equal to 0, we have 0 plus y is equal to 3. Therefore, y is equal to 3. And so we have the point when x is 0, y is 3. Now we have the x-intercept and we have the y-intercept. With the x and the y-intercept, we will be able to draw the graph of x plus y equal to 3. Now, next is the next inequality is x plus 4y greater than 8, and we transform it into the equation x plus 4y equal to 8. Now, next step is to find the x-intercept and the y-intercept. To get the x-intercepts, we simply set y equal to 0 in that equation. When we set y as 0, we have x plus 4 bracket 0, that's 4 times 0 is equal to 8. Therefore, x is equal to 8 from here. And this will give us the intercepts, the points, when x is 8, y is 0. Now, next, I'm going to get the y-intercepts. The y-intercepts. The y-intercept is to set x equal to 0 in this equation. That will give us 0 plus 4y is equal to 8. So this means that 4y is equal to 8. Therefore, dividing both sides by y, we have y is equal to 2. So we have the point when x is 0, y is 2. So we've gotten the x-intercept and the y-intercept. And then for the next inequality, x greater than or equal to 0, for x greater than or equals to, minus 3, for x greater than or equals to minus 3, all we need to do is to draw the vertical line x equal to minus 3. That will be with an unbroken line, a thick line, because the inequality is not strict. And then, so we go ahead to graph these lines in the plane X. We have a value of X as 8. So the highest value of X is 8, and the highest value of Y is 3. We also have values like 3, so we don't have a negative value for X and a negative value for Y, but that doesn't really make. So I'm just going to fix all the points where necessary. I have here is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, here we have 1, 2, 3, 4, 5, and 6. Minus 1, minus 2, minus 3, minus 4, minus 5. Here is minus 1, minus 2, minus 3, minus 4, and minus 5. Okay, and then we have 0 here. Now, the first line I want to graph is the line x plus y equal to 3, using the 2 points, the x-intercept 3, 0, and the y-intercept 0, 3. Okay, for 3, 0, I think the point is just here. And then for the y-intercept 0, 3, the point is here. So we are going to join it, because the inequality is strict, we are going to join it with a broken line. Join with a broken line. Join the points with a broken line. And then that is x plus y equal to 3. All right. Now, the next one is x plus y. Okay, x plus 4y equal to 8. And the intercept is 8, 0 here. 8, 0, and then 0, 2. 0, 2, that's here. And also join it with a broken line, because the inequality is strict. So I'm joining this with a broken line. With a broken line. And that is the graph of x plus 4y equal to 8. Now, next is the line, the thick line, x equal to minus 3, which is a vertical line, which is this vertical line here. The vertical line. This vertical line is a line x equal to minus 3. Okay, next is to represent, now to get the region that satisfies the simultaneous inequalities. We are going to test points in this region. Now, how do we get the regions that are represented here? Look at where the line x plus y equals to 3 and the line x plus 4y equals to 8, where they intersect. From that point where they intersect, we have 4 major regions. Here is one region. Above these points, bounded by these 2 lines, is another region. Then here, inside this place, is also another region. Then this region, bounded by these 2 lines from that point, is another, that's the 4th region. So we have 4 regions here, 1, 2, 3, and then here 4. So we're going to pick points to test each region. Now I'm going to pick the point 4, 4 to test the region up. We are picking points to test the region. Quickly, I'm going to pick the point 4, 4 to test that region, to know if that region satisfies this is the region satisfying these inequalities. Okay, we have 4 using this inequality. 4 plus 4 is equal to 8, all right, which definitely is not less than 3. So for this point, this inequality fails. So that means that this region is not the region we are looking for. Now let's take a point here inside this place, inside this boundary, this region. Let's take this point here, 4, 0. I'm taking that point, 4, 0. Using this point, we have 4 plus 0, which is equals to 4. It's not less than 3. Okay, 4 is not less than 3. So that region is also disqualified. Now, let's pick the region here, the region below these 2 lines from where they intersected. I'm going to pick the origin, 0, 0. If I pick the origin, 0, 0, I have 0 plus 0 is equals to 0, which is less than 3. Yeah. Now, let's test the next inequality to know whether this point is still valid. We have 0 plus 4 bracket 0 is equal to 0, but it's not greater than 8. So that point is invalid. So this region is cancelled, this region is cancelled, this region is cancelled. Now let's pick a point inside this region. So having picked the point inside this plane, I'm picking -1, 3. That's the point inside this plane. Let's see whether that point will satisfy the simultaneous inequalities. Picking -1, 3. We have in this inequality, we have -1 plus 3 is equal to 2, which is less than 3. That's correct. Now, if we substitute into this other inequality, we have -1 plus 4 bracket 3 is -1 plus 12, which is 11, which is in this equation, -1 is here, 4 times 3, okay, yeah, which is 11, is greater than 8, correct? And then if you put this one into that place, we have -1 is greater or equals to -3, which is also correct. So that region will be shaded. The region, this triangular region A, B, C will be shaded. This triangular region will be shaded, which is the region that satisfies this simultaneous set of inequalities. Now, it is necessary to also say something about this vertical line. Why we are not using this side of the vertical line is because the inequality describing this vertical line says that x is greater than or equals to -3. So from that -3 up, from this -3 forward is where we are going to shade. So that means we are not going to shade any region that is lesser than -3. That regions beyond -3, which is -4 and -5 downwards. So from here, that's why we are going to shade here. So this is the region, the required region that we are looking for, because x is greater or equal to -3. So you can now say the triangular region ABC is the region satisfying the simultaneous inequalities above. Okay, so that is that triangular region shaded is the region that satisfies the simultaneous inequality.